Okay, so we are going to prove this lovely relation. Okay, so we got combinations n plus 2 ck. We've got n ck plus 2 n ck minus 1 plus n ck minus 2. Okay, so this is the left hand side and this is the right hand side. So we need to do some algebra to get the right hand side identical to the left hand side. So by definition of a combination, the numerator on the left hand side is n plus 2 factorial. We've got a k factorial, and then we've got n plus 2 minus k factorial. So we need to get the left hand side looking like the right hand side. So let's do that then. So n factorial, k factorial, n minus k factorial. You've got 2 of this, n factorial all over k minus 1 factorial, n minus k plus factorial. At the end we've got n factorial, k minus subtract 2 factorial. Then we've got n minus k plus 2 factorial. Okay, so there's a little trick we can do. I'll show you that trick now. We are going to leave the numerators alone and just get the denominators the same. And when we're doing factorials, there's a way we can do that. So we need n plus 2 minus k factorial. So we can insert that here. And I hope you can recognize that this is 2 iterations before. So we need to insert at the top n plus 2 minus k and n plus 1 minus k. And if you complete 2 iterations of this, you will see that this cancels out and we're just left with the original, which is n plus k factorial. Okay, so let's multiply the numerator. We need k factorial, which is here, so we're going to have to insert a k in the numerator, and we need n plus 2 minus k factorial in the denominator. So we need to insert in the numerator n plus 2 minus k for it to cancel. And then finally, probably the easiest one at the end, we've got n factorial, k factorial, so we need to get rid of a k and a k minus 1, and we've already got n minus k plus 2 factorial. Now you can see the numerator is identical in each, so we can write this all over k factorial n plus 2 minus k factorial. We can factor a n factorial out. Let's open the bracket and we can expand. We've got n squared plus n minus kn, 2n plus 2 minus 2k. We've got minus kn minus k positive k squared. Just going to put that in brackets. So I'm going to do this in one go. We've got 2kn plus 4kn negative 2k squared. And at the end, we are just left with k squared minus k. And we're going to close the bracket. Now I'm going to do the cancelling in red. we have 1k squared. We've got 2k squared here, and we have the other k squared here. Let's do the kns. We got 4 kns there. Okay, let me just check that. We've got 2 kns here, and this should be 4k. There's no n there. Okay, so we've got 2 kns here. We've got negative kn there, and we've got a negative kn there. So there you go. Okay, we've got a negative 3k here. That gives negative 4k, so that goes. So we are left with, do this in n factorial over n squared plus 3n plus 2 all over k factorial over n plus 2 minus k factorial. We can factorize this to get n, 1 and 2, they're both positive, k squared n plus 2 minus k factorial. And I hope you can see that this is simply n plus 2 factorial all over k factorial n plus 2 minus k factorial, which is our original left hand side. N plus 2 factorial, k factorial, n plus 2 minus k factorial. Okay, so that was a really lengthy question, but it's a good question to practice these factorial proofs. Okay, good luck with the rest of your work.